Hello everyone, my name is Dmitry. I'm going to talk about DataOps and ML automation with DVC. The first part of the talk is going to be about principle behind building AI platforms and ML automation. So this part is going to be a little bit abstract. I'm very sorry about that. While the second part is about DVC, the tool that we have built. And I'll show you what kinds of principle we used, we implemented in the DVC tool. So the second part will connect the dots between the abstract concepts and the actual experience, actual tool set. So a little bit about myself. Originally from Russia, a rural place in Siberia. For my entire life, I was constantly moving from the north to south, and now I live in California. I am the author of the DVC tool, Data Version Control. If you are not familiar with DVC, it's an open source tool that implements some principles of DataOps and data versioning. I will talk about this in the second part of the talk. And right now we are building a startup in San Francisco around DVC. So we built DVC, we built some different tools for automating ML processes. Before that, I was a data scientist at Microsoft, and I have seen how large companies are doing automation of ML processes, what kinds of best practices they use, and what kinds of tools they have built. I work with internal AI platforms, and my big belief is those platforms are going to change and will be replaced by ecosystems of the tool. This is what we are going to talk about in the first part of the talk. And I started my career as a software engineer. So I'm familiar with the best practices in software engineering industry, and what kinds of tools and best practices engineers are using. And I think we need to, in ML project, we need to learn from those best practices and those tool set to improve our ML workflow and ML processes. So what learnings, what lessons we can get from the software engineering experience? First of all, it's version control, right? Version control is the foundation behind automation, behind the software development, right? And all the automation in software development is based on version control tools. Today it's usually Git in most of the cases, right? We are talking not only about versioning the code, we are talking about the workflow, about code review, about automating tests and CI/CD process, and even team collaboration is based on version control tool, right? It's we use GitHub or GitLab for collaboration, and Git works under the hood of those systems. But AI systems, ML systems are quite different from software engineering, right? And there are few major differences that we can distinguish between AI and software engineering, ML and software engineering. First of all is ML is metrics driven, right? We need to have metrics in the process, not source code. Kind of a difference between your different versions doesn't make sense anymore. You need a difference between your metrics. You need to understand better how your changes, code changes, or data changes, or hyperparameter changes affect your metrics. The second difference is computational resources. For modeling, you need a lot of memory or GPUs or hard drive to store in data sets, and it takes a lot of time and effort to move your computations, move your training to different parts of your infrastructure. It might be like cloud infrastructure, your local laptop, your internal tools. And in this environment, when computational is always moving around, data transferring and versioning becomes a huge pain point. People spend a lot of time and resources to transfer data, to version data, to make sure that the right version of data was used to train kind of the last model. And we see kind of those differences make software tools not kind of the best fit for the ML automation. So we need to extend the existing tool set, or we need to reinvent a new tool set specifically for machine learning processes. So many teams, many companies, especially big ones, implemented internal tool set for machine learning to support the best practices. I work with one of those inside Microsoft, and you can find a lot of different tools from huge companies, from Netflix, from Lyft, and many others. But my big belief is I see the future of ML systems, ML platforms, not as a monolithical huge platforms, but as an ecosystem of open tools, and especially open source tools. When a team can pick and choose the right tool, chain them together, and build their workflow, which might be very different from the workflow from in some companies, right? The same way software engineering works today. Today we don't have like software engineering platforms, right? We have tools with which we connect together, like Git, CI/CD, code quality control, different like linters, loggers, and so far and so on. I believe the systems, ML automation needs to follow absolutely the same principles. And one of the reasons why we need this ecosystem and not a single platform, not monolithical platform, is it's better to have one single technology stack for AI, for ML, and software engineering, instead of having two different stacks, right? When part of the team will be working with software tools and software engineering tool set, and the another part is will be working on ML toolset. And this is pretty much what is happening right now, and that is not okay to have two different DevOps team for data and for regular software projects. This needs to be this should disappear from the market, and we need to reuse the great tools in ML project that we already have. I'm talking about Git, first of all, GitHub, and other version control providers, and continuous integration systems at the first place. And there are many other tools related to development. So how do I see the infrastructure in the future? I believe we need to extend the toolset or the existing toolset. Git needs to be extended and improved by supporting data versioning and data transferring. We need to include data metrics diff in Git. Otherwise, how can you understand which change is better? How can you understand what was changed between your current commit and the previous one? We need to extend CI/CD systems because we need to bring data in CI system for data validation. We need to be able to bring models, ML models, to the CI system to run model tests. And we also need to train in the cloud through CI system, train in the cloud automatically without any like plumbing in infrastructure. And people level collaboration also needs to be changed. I'm talking about different kinds of UI. UI when team can came together and discuss result of work, result of our weekly work or today's work. And there are many other pieces of this of the ecosystem, but I believe those three are the major pain point that needs to be solved at the first place. And among those three important steps, DataOps is probably the biggest pain point, and which needs to be solved in the very beginning, because other tools can benefit from having a good version control, data version control, and metrics driven diffs and experiment difference. So any ML platform has some DataOps capabilities under the hood. You might see those capabilities from outside, you might not, but this is like an essential, absolutely needed part. This is how you move data to your cloud. This is how you bring the result back and make sure you have a consistent connection between code and data. But we will talk about how to build this DataOps functionality in an open way, in the way that can be reused by other platforms, by other ML automation parts. So we know that DataOps can help to build your ML automation, and DataOps is an essential part of any ML platform or AI platform. In this part, I will show you how those principles of DataOps are implemented in the tool that we have built in DVC, or data version control. So, first of all, let's start from the ideas behind. And DVC implements DataOps principle on top of existing tool Git. Why we made this decision? We made this decision because we'd like to build ML infrastructure on top of software engineering infrastructure. We don't want to reinvent two separate stacks, right? As we discussed, we don't want to have people who understand ML stack and who understand software engineering stack. We believe that the same people can work in both directions, the same team of DevOps. This is one reason. And the second reason, we'd like to reuse great software engineering tools. We'd like to reuse Git itself. We'd like to reuse GitHub, CI/CD systems, and many other software tools that we already have. So, how to implement DataOps principle on top of Git? We use a pretty common these days design pattern, which is called data as a code. You probably know about infrastructure as a code pattern, especially like people who are familiar with DevOps principles. They know this. They know tools like Terraform, for example, or Puppet, or Ansible. When you can codify your infrastructure to some meta files, like JSON files, YAML files, and put these files into your Git repository. So Git repository becomes a source of truth for your configuration, for configuration of your software, of your distributed system usually. So we use the same paradigm. We create a meta files about your data and data artifacts, data pipelines, and so far and so on, data metrics, and Git versions those data. It does a good portion of the work by himself. We just extend the functionality of Git. So let's take a look how the basic principle of DataOps are implemented. What we need to extend in the existing Git tool to make it kind of DataOps compatible, if you wish. And first, of course, data versioning. Data versioning should help us to get back and forth between our version of data sets or models, right? we should be able to get model from like previous month or roll back our production system to the release from the last week. And also we need to connect our data, code, models, like all the pieces together in a one particular commit, right? And this is how it looks like in DVC. You just run a simple command, DVC add, with some data artifact like image directory, for example. And DVC creates a meta file. It puts data in some internal structure and creates a data file which describes what exactly this data means. With all the checksums, with all the addresses of the actual data. Then git commit message kind of connects the data set with the git history, with your code, and probably with a model if you commit model on the same time. The next question would be, but how about transferring data? All right, we know how to version on my local machine, right? Or how can I transfer this data in a server when my training needs to be happened? How can I move the data to my teammate machine, right? So for this functionality, we implemented commands. First of all, we implemented the concept of data remotes. In addition to kind of regular remotes in a Git, right? We invented a data remotes. So you add a data remote in your repository by running DVC remote add command. You specify the address of your storage. It can be like a bucket in S3 or directory in Azure Store, or just like SSH server with some directory. And then DVC push move the data to the server. When data is there and your code is committed and pushed to your Git repository, your teammate can just clone the repository and pull data back, right? This is how you're supposed to move the data between the different pieces of your infrastructure, these different parts of your infrastructure. And the last question would be, but how about metrics? We know that DataOps, it's not only about data, it's not only about files. We also need to know which metrics correspond to a particular model, because otherwise it's really hard to evaluate what exactly is in this file. For this, to cover this problem, we implemented DVC metrics functionality. DVC metrics is just a JSON file with metrics kind of value format. And the DVC metrics div can give you a difference between your metrics in any given commit in the entire repo. You can compare commits between your current branch and, for example, master, or current commit and the previous one. And in this way, you can understand where my best model lives, how much improvements we made during the last week from the Git repository, right? It helps you to quantify everything around the models. So, just summarize. Data versioning is implemented by DVC add, transferring by DVC push, metrics by DVC div, and the actual connection between data, code, models, and metrics happens by Git itself, right? You just commit all these meta files inside the repository, and this is how you do the DataOps with DVC. So let me show you some examples, some applications when DVC can be used for ML automation. In this case, we'll show you how to. This use case shows you how to how to transfer models in your CI/CD pipelines. So you probably know, familiar with the concept of CI/CD, right? This is how you check your code when you make a pull request. When you make a pull request, GitHub runs a specific runner, but this runner doesn't have the data. To make a decision about about quality of your model that was built, you need to transfer the model to the runner, right? And DVC pull can help you to transfer model into the runner, and then you run your specific code, or you just show two outputs of your inference before change and after change, and the team can make a decision how good the model is. In this particular case, we run inference, style transfer inference with current change and a master branch, right? And by your eyes, you can take a look at the difference and make a informed decision about the change, how good the change is. In other cases, metrics might be a better way to kind of make a decision, to quantify your decision, and team can have more information about the change itself. And DVC metrics can bring this functionality in your CI/CD pipeline. When you run metrics diff and see the difference between your current change and master, which usually correspond to your production environment, and by the metrics diff, you can make a decision how good the current change is. Does it make sense to merge it to master and replace the and go to the next version of your code in production system, for example? So that's how this ecosystem of the future can look like, and this is what we are working on. We believe that this ecosystem needs to be open, needs to be open sourced, and we work on different pieces, different building blocks of the ecosystem. We extend Git by DVC functionality, by adding data metrics and data transferring functionality. We extend CI/CD systems by implementing CML project, which helps you to bring metrics and graphs and plots to the CI/CD reports. And also we are working on something similar to GitHub. We'd like to extend GitHub by metrics and data. We'd like to bring collaboration experience around metrics to a service when the team can collaborate, when the team can see the results, the history, the trends of their ML projects. So thank you very much for your attention, and I'm open for your questions. Thanks.